All right, we're back. We are COMP308 in the winter 2017 semester at Centennial, and it's Emerging Technologies. It's week 8, part 2 of our broadcasts. I don't know why this is Emerging Technologies here. That's a mistake. I got to fix that. But anyways, what we're talking about today, for the second part is Angular 2 and TypeScript. So if you noticed online, there is an exercise for today, a lab that's due for tonight, midnight, right? Where you're to do the Tour of Heroes exercise. If you go to angular.js.org, and if you go to try the new Angular, yeah, this is a you do thing. See, I've done me for 2 hours, and now it's your turn, right? And if you look at docs on Angular.js, so I went to angular.io. If you go there, go click on docs. On the left, you can see tutorial. And there's this tutorial that says Tour of Heroes. Actually, if you look up on the lab, the link is there too, right? What I'd like you to do is, while I'm doing this stuff, I'm going to talk about this PowerPoint stuff. I want you to listen with your left ear and watch with your right eye, and then do the tutorial while we're talking, right? So that way you can finish it by the end of the day, right? So you don't have to worry about doing it tonight because it's due by midnight, right? For 2% bonus, right? Okay, what is this thing that we're building? If you look at the live example here for Tour of Heroes, it's right on the Angular site. I think it's a great little tutorial. It gives you the ins and outs of basic Angular, like AngularJS 2 101, right? And what does it do? You have these heroes. I got Narco, Bombasto, Celeritas, and Magneta, right? And you can do a little hero list. So here's my hero list based on most popular heroes, Mr. Nice, right? And Tornado, there's another one that someone else made, right? And if I want to, I can add a new hero. So let's make a new hero name. We'll call him, Mr. Mean, right? There we go. And then we added my hero. Here's Mr. Mean down here. If I click onto him, I can view my details. And this is all done with Angular JS2 only on the front end, right? So you have this little thing that's happening. So here's my dashboard. Go back here for the most popular heroes. I can do a hero search. So I say Mr. Mean, right? And there it is, right? And you can give him his details. So lots of really cool stuff here. It's a very simple app, Tour of Heroes, but it has many parts. And if you notice on the left-hand side, here's a great example of all the piece parts that you're going to have to create for Tour of Heroes. Where do you start? Okay, you don't start there, that's for sure. What I'd like you to do, and don't download the example, okay? There is going to be there's 3 parts to your upload to get your full marks. 1, you need a GitHub link. So please make a GitHub repo for today, right? It can't be the one that I'm working on. It can't be less than 8 because it's not going to work. It's not a Node application. So if you try and make it work with Node, you're going to bury yourself, right? It's a non-Node application. It's a front-end application. You need to make this live on some site. Put it up on on Azure or on Heroku or whatever, or somewhere else, right? Now remember, it's a straight HTML page, which means Heroku won't take it unless you put a Node part of it. Make part of it, being generated by Node. And there's ways of doing that. So Azure might be the best option. The other place you can run this nicely would be up on GitHub pages because it doesn't require any backend whatsoever. Okay, so GitHub pages might be the other option. So GitHub link, some kind of live site, and your files, which I want you to name appropriately. Call it something like COMP308, winter 2017-lab 3. Okay, that's what you're really doing today, okay, for your 2%. So you start off this stuff. If you scroll down, if you're on the left-hand side, here's your introduction. The introduction really talks about what you're building, right? And it talks about how it all works. This is a good understanding about everything, how it does two-way data binding, like this, right? And let's click on here, the hero editor, the next step. And here's where it says set up to develop locally. And it says follow the setup instructions for creating a new project named Angular-Tour of Heroes. In your case, you could leave this same. I would accept this as well, but I recommend you make it so that there's no contention. You make it COMP308-lab 3. That's what you change here, okay? The project structure inside doesn't matter, although I recommend sticking with some of our best practices. Try and make it so that you can use, instead of styles being hanging out here under in the source files, put it in a content folder, right? Keep app the way it is. Notice how it's been configured, right? You need a package.json and node modules and all that kind of stuff. That's your application structure, right? And if you follow along, it tells you how to put everything together. So that thing is due tonight at midnight. And again, one thing I'd like you to do, and one of the instructions online was add 3 of your own heroes. So don't just use Bombasto and whatever, make your own, right? Any questions around that? All right, so please follow the tutorial. It's a very good tutorial. It talks about master detail, multiple components, services, routing, HTTP. It covers a lot of the stuff that we're going to be talking about for Angular 2. And the great thing about this is if you do this, the next week when we go into full CRUD, you'll have already done some work with Angular, right? So it's not going to be completely foreign to you, okay? And also remember, this is not going to be our last step with Angular. Angular, even though it's not going to be required on your final project, I'm going to make it an option, right? It will be a bonus option, something you can add in for additional marks, right? To add an Angular front end. And your final project you're going to be running with you and another 3 people if you're thinking about doing this on your own. Assignment 3 will probably be based on something to do with your microservices, and I'll probably be giving you that either next week or the week after, right? Which is coming. So look forward to that one. And that'll be your last assignment, assignment 3. Okay, so again, think about the assignments. They're 15% each. Assignment 3, that's 3 of them, that's 45, plus 20 for your midterm, right? That's 65, and the remainder is your final project, right? So it's 35%. And how I'm going to break that out is you've got a piece that's going to be your presentation at the end, and then several pieces for your several releases that you're going to do for your, or milestones, if you will, for your final project. Okay. All right. So that's your hero editor, your tour of heroes. Please do that. Don't wait. Start it now. I'm going to talk about Angular now from a very high level, and I do have a PowerPoint that I'm using for this one, and it took me a while to put this together because there were several issues with this. I was saying the other class, I basically took about 3.5 hours to troubleshoot the problems that came from the book to put it together. So that kept me up until about 2:30 this morning, 2:30 this morning, 2:30 this morning. I'll be okay. Speaking of which, please remember to put your clocks back an hour, if I'm not wrong, or is it forward? Spring forward. Spring forward an hour. That means you're going to lose an hour. 1 hour less. That means next week when we get together, it's going to be like 7:30 in the morning, or 12 o'clock instead of 1 o'clock. Okay. All right. Let's get to this. So if I look at Centennial and we go to COMP308, then online I put a lesson 8, which is Intro to Angular. I have to admit to you that this part of the course is the most difficult, challenging part, because of you're adding on top of everything we did with Express Node and Mongo, we're adding on stuff, right? Which makes it always more challenging, right? All right, Intro to Angular. Let's get to it. So this part is going to include TypeScript. We're going to talk about TypeScript first, and Angular 2, a little bit about the building blocks of Angular 2 and how to install and configure TypeScript in Angular, a little bit about how we create and organize Angular 2 app, right? As well as utilizing Angular's components architecture. This part I'm not going to do. This part here I leave to you if you want to explore it. I'm going to do more of this next week, right? Which is implementing the authentication component. That's part of the book, the app that's in the book, right? And the reason for this is because it would be several pages longer. I would have to make this, instead of a 78-page PowerPoint presentation, it would be like 120 pages. There's a lot of additional pieces to this to get it going, and I want to try and save some of this for next week. Okay, so this is the first part. The first part is what we're doing is talking about TypeScript. So first of all, what is Angular 2? And make this really big so you guys can see it. Really, it was based off this idea of producing a single-page application. Single-page application means that in one page, one physical HTML page, you could have several quote-unquote pages or sections. And it would appear that the page would load without accessing the server. And we did that with Ajax and with jQuery Lite. JQ Lite is what it was called, right? Angular 1 was based on the fact that it was running with ECMAScript 5 technologies previous. And so they didn't have access to the new specifications. And they ran into some problems, some theoretical scaling issues with Angular 1. Angular 1 migrated from Angular 1 to Angular 1.5. And Angular 1.5 went as far as they could with a component-based model. Then they were moving on to Angular 2. Okay. So they took the best parts of Angular 1 when they migrated, and the changes are the following. Syntax. We're using TypeScript now for syntax in ECMAScript 2015. Syntax for JavaScript, right? So anyone not know what TypeScript is? Has anyone not had me for COMP397, COMP392? No, you don't know what TypeScript is? All right, cool. So what is TypeScript? People have had me. Some people love TypeScript. Some people hate TypeScript, Selena. But it's, you know, it's not her fault. She's just like, okay, Tom, I've had enough of TypeScript. It was too much for me. Remember? It's hard. It can be hard. It can be confusing. So where do you find TypeScript? TypeScriptLang.org. There is no way of getting around it, guys and girl, right? TypeScript is here to stay. TypeScript was a technology developed by Microsoft to make JavaScript easier. It is a superset of JavaScript. That's what it is. It wraps JavaScript with something that looks more object-oriented, okay? And you got to think about this. Microsoft came out with this thing several years ago now. Before TypeScript 1 was out, I was on board. I saw it. I was like, wow, this is really cool. And making games with JavaScript was way more difficult. But with TypeScript, you could modularize your games. You could take an object-oriented approach. Lots of really cool things. With TypeScript, what you have is the idea of typing that's added on. So I'm just going to make an example here. I'm just going to kill all this and start over. So normally in other languages, you might have something that looks like this, right? I might have something like a class, right? And inside there, I might have a person class. Here's a person class, right? And the person class might have some instance variables as well as some properties, right? So my instance variables might be something like, I don't know, name, and it might have a type, string, right? And it also might have a age, which probably is a number. Notice that there are different types here, right? I also might have a constructor, right, in let's say Java or C#, right? And it usually takes the same name as a class. So if it's in C# or Java, or even in C++, the name of the class might be person, and the constructor would be person. Not so in TypeScript, it would be constructor, right? Which is kind of makes sense, right? So the constructor function itself, right, is the initializer function. In Swift, it's called init, right? The init function. It's the initializer function. In C++, you have to indicate what the function is, which class the function comes from. But more or less, it's the same. Most object-oriented programming languages have some kind of constructor function called something, even Python. This constructor function is initialized when you create an instance of the class, an object of the class, the constructor function triggers, right? It gets called automatically, right? Same thing happens here. So what we could do here is I could listen for a couple things. I want to say the name. I want to get a name for the string and an age, which is a number, right? And then what I can do is I can use this keyword, this.name is equal to name, and this.age is equal to age, to assign our instance variables to the local variables that I'm taking into the constructor. You guys should all be following now because this is just regular object-oriented methodology and design, right? Notice what I'm getting here. Oops. Notice what I'm getting here on this side. And notice what I'm getting on this side, right? This is TypeScript, and this is pure JavaScript. Easier, harder, right? A little bit, right, to understand. Notice that the JavaScript version uses an IFI, an immediately invoked function expression or a closure to close off this class definition, right? And inside there, we use function syntax to denote a constructor, right? Notice that there is no local variables or instance variables that are declared, and all you do, there is no typing either. So typing, string, and number. Types don't exist in JavaScript. They only exist in TypeScript. So why do we need types? Doesn't this make things more difficult? Isn't it less flexible? It's a little stricter. And what it does is it gives us good code hinting. And that's what really TypeScript does for us. It gives us good code hinting, and it produces this object-oriented design methodology that we can use that we're all used to, right? So if you're a C# developer, you love this stuff, right? Because some people who are C# developers or Java developers hate JavaScript because it's like, wow, it's so unstructured. It's, you know, you get into this callback hell, function within a function within a function. Here, you don't see that structure, right? You transpile from TypeScript into JavaScript. That's what you do, transpile. And it produces this. This is actually called emitting. This emits perfect JavaScript over here, ECMAScript 5, right? All right, let's also talk about methods. So here's some methods. And under the methods calls, we can see that our method might be something like says hello, right? Here's our method says hello, which returns void, right? And in the says hello method, we can use a console log, right, with a backtick. Remember, backtick is the new ECMAScript 6 string interoperability capability, where we can say something like this. We can say $ open curly brace, this dot name says hello, right? And what this does is actually interpolates this dot name, which is the name instance variable, and pops it in there. This is a placeholder, right, where it pops it inside, or it injects it in here, and it says this dot name says hello, right? Notice what it does on this side. This is the JavaScript side. And we use something called the prototype keyword. If you've never done any object-oriented design, remember, for JavaScript, JavaScript is not really object-oriented necessarily. It does object-oriented like things, but a lot of times we use prototypal inheritance. We use prototypes for inheritance and to declare classes, whereas here we use class structures, right? The new version of JavaScript, ECMAScript 2015, does use the class keywords and class structures, but it does not have any typing. There's no, it's still dynamic typing. It's not strict typing like we have here, okay? So you see that this is what it's emitting. This TypeScript, we say, emits this ECMAScript 5 level JavaScript. And you can choose through a tsconfig.json file, a configuration file, what kind of JavaScript, what level of JavaScript TypeScript will emit. Okay, that's what it does when it transpiles or compiles. That's what it's like. It's like compiling, but it's not really compiling because it's not a compiled language. It's a transpilation process that translates TypeScript, superset of JavaScript, into pure JavaScript of one form or another. Okay, so that's what this does. Well, this is nice, but how is it looking if I create an instance of that class? I could say there's something like let Tom equal to, which is actually, I can type it here too. Tom is actually a person, believe it or not, and he's got a new, we're gonna instantiate a new person class where we're gonna pass in his name and his age. Okay. Well, I don't know. Let's leave it at 30. And then Tom dot says hello, of course, right? Which would generate that says hello. I think if I run this thing, it actually will generate this says hello. But anyway, actually, it'll do that in. Sorry, it will do that, but it'll do that in the console, right? Tom says hello, right? So that's what this really does, right? And notice that the JavaScript on this side. So it's very similar. And one thing to note is if I took this JavaScript as is and dropped it into TypeScript, it would work. Any JavaScript runs in TypeScript. TypeScript doesn't do that. TypeScript translates this to this, right? Okay. Now, where it gets really hairy is when I want to do inheritance, right? I want to create not a person class necessarily, but I want to create a professor class, right? Or a student class, right? Let's try this out. So I want to say class, right? We'll say professor, right? You notice what's happening on the right-hand side as I'm typing, right? My class professor, what it does, now here's where it goes crazy. Ready? Extends, right? Person. All right. This is kind of this part right here, this extends method that we're doing up here. What it does is it mimics what it's like to truly do inheritance with class-based architecture, right? It's not really the same. It's still using prototypes, but we're mimicking, or we're trying to make it look like it's doing it. And it works just the same at the end, right? And what we can do is, again, we can have some instance variables. We have some instance variables here. And we're going to say one of the instance variables that the professor has that a regular person may not have is maybe an employee ID. So we'll say employee ID, right? And that's going to be a string, right? And we're also going to have a constructor, custom constructor for this one. And when I use a constructor, what I want to pass in is, again, a name, which is a string, and age, which is a number, and maybe the employee ID, right, which is a string as well. And I'm getting an error. And the great thing about TypeScript is it does this stuff. It gives you these errors, and it says, if you hover over it, it says constructors for derived classes must contain a super call, right? That's what it calls. So that's part of the language, right? So I need to call a super, and inside there I'm going to pass in a name and an age, because that's all the super constructor requires, right? This sends the information to the super constructor, and now I can also have my own methods. Right, so here's some more methods, and then we'll make this method public. By the way, you can notice I can put public and private. It won't make any difference on the right-hand side. What are they used for? Code hinting, tooling, to help me troubleshoot, right? So my method public maybe is lectures. He lectures something, and it returns void, and I can do the same thing, console log, where backtick, $sign, this dot name, right? Lectures a lot. There we go. Okay, and we can close that off. And now when I do this, notice that if you look at the class on the right, so here's my person class, and there's my professor class, which extends professor, right? That's what it does. Professor extends the superclass, which is relating to the person itself, right? It's very interesting the way it combines all this stuff. Still uses prototypes for everything. But notice that in the bottom, it's still part of the person class. Right? It's very interesting. And what I can do is down there, do the same thing. Let Tom now be a professor, right? Which is a new professor. And pass in his name, age, and employee ID. So name, age, and employee ID. Right? There you go. And then I can still do tom.sayshello, and I can also do tom.lectures, right? Oops, I keep doing that. I want to save. So that's cool. So then I run it. If I run it, you can see that on the command line, now we should have both of those lines, right? So I've created two classes, right? One inheriting from the other. And the other thing that's missing here, notice that I'm having a name and an age, and I can take this one step further where if I can not only do classes, but I can also use interfaces. And where my interface is called the person interface, right? And maybe the person interface needs some kind of name, which is a string, and age, which is number. And I can say that, well, person implements the iPerson interface, right? And remember that implementing means that we accept this contract of how we're going to structure or shape our objects, right? Which creates a pact between us and people who use our classes and objects so that they're used properly and give good feedback, right? Also, a great reason for using interfaces is if I want to create a small type. For example, if I was making a playing card object or deck of cards, right? And in my playing cards, I have faces, right, and suits, right? So my suit would be one property, and my face value would be the other one, right? And my interface would be card, right? And if I wanted to make an array of cards, I could do such a thing, right? And I don't have to declare a whole class for that, just an interface. And it's going to give me the same tooling that I would get for a class. It's really kind of an interesting way of doing things. So any questions around the rudiments of TypeScript? This is kind of a very high level view of TypeScript, 30,000 feet kind of thing. Documentation wise, it's great. There's no better place to learn TypeScript than on the TypeScriptLang.org site, right? Why? Because all the documentation for handbooks are here. It talks about basic types, which are things like numbers, strings, booleans. There's also an any type. Here's an array. That's how you declare an array. You can also use this form for an array of number types, right? They also do tuples, which is something new, something that was borrowed from languages like Python. Python's been using tuples forever, right? Enumerations, which is something else you can add in now with TypeScript, and other language features. The any type is kind of weird. It's kind of like a super type, if you will, or what it does is it basically says, look, if I don't know what it is, it's type any. And sometimes we use type any to solve problems. We don't know how do we assign a type to this particular object. We just say any, right? If you want to give it a type. And if you don't implicitly or explicitly say, sometimes it will implicitly determine that on its own. Because remember, TypeScript and JavaScript can use something called type inference, where if it walks like a duck and sounds like a duck, then it's a duck, right? Quacks like a duck, it's a duck. So that's the thing, it's duck typing, this idea of duck typing, where we look at an object, what does it do? Well, whatever it does is what it is, right? It's almost like, if you're a teacher, then you must be a professor, I guess. So that's what the any type is. And sometimes when we use the any type, we can also think about us not using TypeScript at all. Like we're avoiding using TypeScript by using the any type. So it's kind of the lazy man's way or a workaround sometimes to get around certain things. Or if you want to we want to maintain the flexibility, which is one of the arguments around not putting types in JavaScript is, hey, I want to maintain the flexibility of JavaScript and I don't want to be tied down to a specific type. I want to have a flexible type. Then the any type is the way to go. Void is also a type, null and undefined. There's also the never type, right? There's all kinds of other stuff, and you can keep going. They've got some awesome language features that they keep on adding in. The other thing to note is that there are classes, right? Like I said, and I've touched upon how to do classes, and they also talk about how to do inheritance, and they have some really good examples of inheritance, multiple inheritance, and so on. Public, private, and protected modifiers, which are primarily used for us for just for tooling more than anything else, because it doesn't really do anything. When you emit pure JavaScript on the other side, it's just, there's no modifiers, right? So it's just really for us on our side. But it does provide errors. It creates errors if you're not using things the way they're supposed to be used or meant to be used, right? So this is that stuff. There's read-only modifiers. There's also getters and setters. There's accessors for getters and setters, really, really important. Get accessor methods and set accessor methods. Private instance variables, public properties, right? That whole concept, it kind of adopts that stuff, right? So those kind of things. How it does functions, it does generics, symbols, iterators, generators, modules. So it does modules in a very cool way. We're going to see that a lot with the export keyword. You can export individual things, as well as you can export the entire module. You can also use the import keyword, like I said, to derive a value, make a reference to an object that comes from the entire module. And we've seen that already in modern Node.js with the require keyword. But when we use TypeScript, we don't need the require keyword. We can use import whatever from the module that we're getting stuff from, and it's the exact same effect. In fact, if anything, we get better code hinting using import than we do with require. Okay, so that's really kind of cool. So lots of really cool things all on TypeScriptLang.org. They're moving quick with TypeScript. If you care, you can always look at, if I look at TypeScript milestones, it has the GitHub repo on it. You can see that how many issues open and closed they have. They're moving towards TypeScript 2.3, and there's 110 open issues right now. There's 62 closed ones, and as they continue to march forward, they'll probably release another version of TypeScript fairly soon. Okay, and that's how they do things with TypeScript as well. They're very transparent when it comes to that. You can see that you can actually look at the TypeScript code. There's 16,000 commits, right, that they've done. So it's quite a busy, project. And you can see how long it's been in place, how they've been doing stuff. So if you really want to take TypeScript and take a look at it and open it up and see how it works, it's an open source project by Microsoft that you can look and see. It's really quite good, and I'm I'm quite happy with what they've done. So that's TypeScript, and that's really one part of what it says here in the book. Syntax that we use in Angular 2, it uses TypeScript. Can you choose not to use TypeScript? Yes, you can, but not recommended because it's built for TypeScript, right? Modules and controllers. Controllers have gone by the by, right? It used to be controllers in Angular 1 because the whole model view controller kind of pattern, but they moved away from using controllers and moved towards using something called components. So they've used a component-based approach to plug in functionality to your code, right? So when you do your Tour of Heroes lab today, hopefully most of you will do that to get your extra bonus marks. And you know what ends up happening, right? The people who get the bonus marks, the people who don't need the bonus marks. I keep on saying, yeah. And the people who don't do it need the bonus marks, right? So please, if you're someone who needs bonus marks, these are 2 free % final marks that you're going to get if you do this lab, right? So get cracking. It's due by midnight, right? This is lab 3. Yeah. Lab 3, yeah. So if you missed lab 1, 2, that means you've lost 4%. So let's take a look at this. Scopes. There used to be a scope variable in TypeScript 1. Angular 1. There is no more scope variable. It's gone away, right? And again, we use the component model to take care of that. Decorators, yeah.
Does TypeScript along with JavaScript help with Android app developments at all?
Yes. And we're going to cover that with Ionic 2, right? So we're going to get to one of the modules I want to kind of cover with you guys is how to build a mobile app with Ionic 2, right? So we're going to do that. And Ionic 2 uses Angular 2 and TypeScript, right? So very, very cool stuff. So you can't do that unless you've done this. So it's a good opportunity for us to do it together. All right, so scopes, decorators. They use the decorator pattern, and the decorator pattern is really what it is think about this as annotations. We did that type of annotations before with COMP309. People who did COMP309 with me, we did annotations with C#. Same idea with decorators, right? We're going to talk about that. Dependency injection. Interesting. They used to have a dependency injection, which is inversion of control from a software pattern perspective in Angular 1. Now they've added multiple injectors that you can use in Angular 2. By having an injector matrix, that's what you're creating, or an array of dependencies, as some of you have noted. So very, very cool stuff for Angular 2, and it's been a while in the making. I really was concerned that Angular 2 was going to come out and React was really going to take it over because React was the competing technology. But it's a different kind of thing. React is not a framework like this, right? React is simply a front-end API that you can tap into. It's very, very cool, but it's not like that. It's not an Angular at all. And actually, Angular speaks to me more than React does, to be honest. All right, introduction to TypeScript. Let's take a look at this. So we talked about all this stuff. I'm not going to go into too much about TypeScript. We've actually talked about all of this stuff. One thing that they do mention is, unfortunately, static typing didn't make it into ECMAScript 2015. One thing that you can always check to see with ECMAScript 2015, if I go, can I use? I always like to check this out. And if I put in like something like class, right, the class-based stuff, you can see that already ECMAScript 6 classes are covered by 72% approximately of the world's population, right, when it comes to browsers and technologies. That's pretty good. It means, so we need TypeScript for 30% of the other people, right? The other people that don't use a modern browser, like IE 11 or earlier. And notice it just says IE 11, right? And it's only 4%. But what about IE 10, IE 9, IE 8? There's lots of stuff like that out there. Same thing with older versions of browsers. The older browsers don't support it, and that's why it's only 30% or 72%. Opera Mini definitely doesn't support classes, and neither does the old Android browsers. So you're going to get some percentages from there as well. But that only equates to about 10%. The rest, the other, I would say 20-something% or 18% is covered by older browsers, right? So that's why we need TypeScript. We need TypeScript to bridge that gap, right? So we can use class-based architecture across all browsers, right? So can I use? So again, we covered this part and how to do this kind of thing, and the any super type, that's what we call it as well. The interface types, we covered all those things, classes, and decorators. And I think this is important to see how the decorator pattern looks. You have a function, as an example. You can define it separately up here. And you can use the decorator down here. based on the same function name. And then basically what it does is it modifies the class that it sits on top of. So it has to be like right next to the class. Can't make them separate. And that's the decorator pattern. Decorators are an ECMAScript 7 specification that they're trying to accept. It's something that they're working on. And when it happens, eventually I think what's going to happen is TypeScript is going to go bye-bye because we're going to have most of its features inside modern JavaScript. But for now, it's still around, it's still necessary. One thing to note, because we are emerging technologies, is the rise of something called WebAssembly. Anyone hear about WebAssembly? WebAssembly is something new. It's a new project that's been around for about a year now, I guess, or more. And what WebAssembly is they use C++ to create an assembly-like matrix on the back end that browsers can use to have a really speedy kind of interface. In fact, you can get near real-time, near native performance from your browser. That's WebAssembly. Something new and on the rise. Notice again, primarily in C and C++. There is all kinds of stuff. Can you use it now? And again, if I was going to go to can I use, right? If I put WebAssembly, so WASM is what it is. Right here's WebAssembly. You can see that not a lot of support yet. It's like 0.31%, right? But this is on the rise. Both browsers, both most popular browsers in the world right now, Firefox and Chrome, I would say have both adopted it, and they're green for the latest versions. So both version 59 and 55 of Firefox both support WebAssembly. And in fact, this is a Firefox or Mozilla initiative. It's not a Microsoft initiative. So this is really kind of neat when you see different companies kind of coming up with this new technology. I think it's going to be the future, my friends, because with WebAssembly, we're going to be able to do something like WebVR, right? Where we can wear something and do virtual reality with web technologies, not just with things like C and C++ or machines that require all kinds of hardware. So I think this is the future where we're going to go. So WebAssembly is something we should keep an eye on. And eventually, if you think about it, right now it's C and C++, but tomorrow it could be something like TypeScript, right? Where we convert things from TypeScript right into WebAssembly, right? And I think that's where it's probably going to go, something like that. All right, so that's really kind of cool. So that's TypeScript in a nutshell, like we said. Okay, let's take a look at Angular 2 now. So Angular 2 is something that's a bit of a beast, okay, to talk about. And you guys have been, I know of some of you who already started the lab, you can always see how, how interesting and different putting together. What happened to your machine? What? It's dead? Okay, there it is. It's dead. So Angular 2, really the goal was really simple. HTML and JavaScript, bring them together, make them manageable, make them ultimately scalable, right? But they wanted to use a component-based architecture, so a plug-in kind of architecture, very modular in design, that was, a little easier to use. You want to support entities such as services and directives, right? And a component is a directive, and we'll talk about what that is. What is a directive? And the whole idea of a clear separation of concerns was really, really important, where things weren't tied together so tightly with controllers, and you can really work on one module, like one little module, one little component, and you can give that up, give that to that person, give that person this component to work on, let them test it, let them work in it in a lab environment. Okay, good, they tested it, it works great, bring it in now, and I can plug it into my application. That's where they're going with Angular 2, and that's why, on some ways, it becomes interesting to use. On the other side, it's complex, right? Because they're trying to make it so it's pluggable, right? Once you start making this flexibility in your code, then there's a whole overhead in how to create that plug-in ability, right? And you can see that they've kind of created this. This picture comes right from the book where they kind of talk about this, the basics of Angular 2, the idea that you can inject a service into an authentication service. The authentication service will authenticate, use the authentication component, but there's also this other idea of this home template that plugs in through a bundle directive for the authentication template so that you can render the template. And it's a kind of convoluted picture here, but one of the things that you can see here is this is two-way data binding, right? So again, Angular 2, whenever you think about Angular 2, I want you to think about modular applications, about components. That's what it's all about. And with each component doing a single task. Okay, that's really, really important to think about as well. And we're going to be able to import only the features that you need, right? And leave out the rest, like a Chinese buffet. Eat what you want, leave the rest, right? And again, we have some really cool modular syntax. This is the module syntax. Doesn't this look familiar? This is read from TypeScript, my friends, right? Import a module from Angular core, right? Import this common module from Angular common. And these are all the common modules that we're going to get. Well, actually up to here, these three are the common modules we get from Angular, right? And then what we do is we have a couple of our own. We have app component, which is a custom component. And we also have our routing. Here's our routing, right? And then we use this something called this ng module directive, right? This decorator, right? And it comes from here to about here. The @ sign is the decorator symbol, right? ng module specifies that this is the main module, the app module, the manifest for your application on the client side. We've been doing applications with Express on the server side. This is strictly client-based, okay, for now. Notice we have imports. We import our common module and our router module, right? That's what we're doing here. And we also have declarations. The declarations are almost like dependencies. So these are our declarations. We have our app component, and this is our custom component in this case that we're plugging in there, right? And when we say Bootstrap, Bootstrap is not Twitter Bootstrap. It means how do we start our application? Which module starts our application? And it's the app component module in this case that does. Okay. Notice how we are actually exporting our app module from here. So this is our little module. We export it, and we later on will consume it. We'll eat it, or we'll import it. So again, component is the essential building block, right? The job of the component is to control the view. That's what it is. So think about almost like a tightly coupled controller, right? Or a code behind file for the view. That's what I want you to think about. If you're looking at ASP.NET technologies, and if you've done code behind files in the past, it's very similar to that. So where each component handles a single aspect of the view, okay? Okay, so we basically create the component, and then we export the component back into the module that we want to use. Here's what a component typically looks like. We have a component coming from component. It comes from the Angular core library, the idea of component, right? We have a couple of attributes, selector as well as template. Selector is the custom selector name that you're going to use in your application. So a selector could be something like HTML or div tag or a anchor tag, whatever. We're making our own here. We're using mean-app. That's our selector. And wherever that mean-app opening and closing tag is, that's going to be the container that's going to house our template. So our template, this part right here, is going to be injected inside of the opening and closing tags of the selector that we are defining. All right? Are you understanding this? So we have our mean app, that's a selector, and we're injecting this template. When we say template right now, this is an inline template. So it's only one little H1 tag with a little bit of text, right? Notice down here, export this app component. Well, my export keyword comes from TypeScript. My class comes from TypeScript. This is a TypeScript class that doesn't have a constructor, right? It's just an empty class right now. And what we do here, this combination of component and class makes it so that we don't need to instantiate a new object of that type, right? So I don't have to make a new object of app component. We just import it. And every time we import, that is the instantiation of that class. The importing itself instantiates the object, okay? Templates. We use templates to render components views, right? That's what we do more than anything else. And we use annotations to help us with that. So here's an example of a template URL. We did the other way. back over here. This is a template we can use this way, where we have an inline template with, let's say, one line of text, pretty much, right? But more commonly, we use something like this, a template URL, which points to a specific file, so the template itself. And the template could have like 5 or 6 lines of code. That's all it does. And it basically, you take that and it's injected, all those lines of code are injected inside the tags, the opening and closing tags that say mean-app. That's where they go, right? This is an example of one-way data binding, where we send stuff to the view, all right? Let's talk about data binding a little bit more. The idea that we can bind data from the class or the component to the view is the central idea for Angular, all right? If you don't understand this, then using Angular would be impossible, okay? Let me explain this a little bit clearly. When we use, we inject data, like one single value, we use something called double curly brackets to do it, or braces, right? Sometimes we also call it mustache syntax. Ooh, if I can say that 10 times fast. Mustache syntax, mustache syntax. So if you look at the mustaches, it looks like 2 mustaches, right? And anything between the mustaches is the values. This is the title. Notice the title comes from our class, our TypeScript class. TypeScript class has a string value, which means what type is this by inference? String. All right, so title is a string. It has this value. It injects mean application into anywhere that has these mustaches, right? So that's how it injects. It uses this as a placeholder, right? Interpolates is what it's interpolating this information, right? And so in this case, again, this is the third idea of a template, right? The first one was a template with an H1 tag. The second one was a template URL pointing at a file. The third one here is a template that uses an injectable area, right? This interpolation that takes a value and interpolates it or injects it in. And we've seen that with Express.js, right? With our EJS, right? With percent less than percent equals, same idea. That's just that syntax for Express. This is the syntax for Angular. All right? One-way data binding is what we've seen already, right? But what about if we want to do things like change the property of an object, right? Or what we want to do here is we want to do property binding. And property binding is, here's a property in the class, is button disabled. This is a Boolean property, true or false. By default, in this case, it's set to true, right? With square brackets, we can use the property that is defined by Angular. So disabled is an Angular defined property where we can enable and disable components on the view, right? In this case, is button disabled in quotations points to the value of this property that's inside the class. So it's either true or false. In this case, it's true, which means this button by default is disabled. Make sense? Square brackets tell us that this property, we inject this property for this button. Okay. Do you get this? Very nice. Okay, and then we have something called event binding. Event binding uses round brackets. So we have a button, and we put click, the type of event, inside the round brackets. Click, hover, move, whatever you want to be, right? And then whatever's in the quotations after that is it points to the method or the callback that is the event handler. So in this case, when I click on this button, I show message. I call the show message method, which actually puts up an alert that says this is a message. It's a callback method, right? So this is event binding. These are all things that you can do with templating in Angular. Two-way data binding. Two-way data binding, we actually combine our template with our model. Model usually means some kind of data or access to data. So here's an example of two-way data binding where we use both round and square brackets for the syntax, right? So here's a round bracket. This looks like an event, and then the square brackets outside. So we have put this syntax, square and round, together like this. This is called, right? This is event. This is where we're putting in our value, or we're injecting, interpolating values here. If we're going to set a property, like for example, that is disabled property, that's property binding, There's event binding if we're going to make a click, the button click, and then now this is two-way data binding. And two-way data binding, what it does is this. When we type a name inside of an input, it automatically, or I should say automagically, right, inserts this data in real time. So if I type in my name, boom, it's there right away. And you can see that in the Tour of Heroes example, where you can inject data automatically. The other thing is this two-way data binding is this title is what's happening. And but this ng model property, again, is called a directive. In fact, all components are directives. Let's talk about directives a little bit. So there's different kinds of directives, and these are attribute directives. Attribute directives are things like ng class, which provides a way to bind, like it says here, single or multiple classes to an element. This is a class. It's in like a class, not a class, a CSS class. This is a class that comes from the Angular model, right? And ng style, which does inline styling. I don't recommend this, but you could totally do that, right? And sometimes we have to, like a bold or a different color or whatever, special effect. The ng model, what it does create that two-way binding connection between our element and the class object. The other way to do it is something called structural directives. Here's one, ng if. You can use this to say, well, ng if this value is equal to true or false, add or remove a component. You can add or remove it, right? ng for acts like a for loop, right? That's what it does. That's the syntax for the for loop. So you can have ng for, and then in there for every, for every game in games, create another list item. Keep creating list items for every game in games, right? ng switch is exactly what it is. It's like a conditional statement, but it might have a series of conditions. Instead of if else, there is no else. You use switch, right? So these are called structural directives. Okay. All right. And these are component directives. Component directives look like components, and you might have a selector, that's a directive, as well as a template, that's a directive, as well as other ones inside here as well. Like, for example, a style. And you can always try it out by going and start putting in a directive. So far we've seen the idea of this component, and this component will be called something called sample component, right? Notice that we're exporting the class called sample component at the bottom. This will be like your module export, right? I'm exporting my sample component. Great. Here's the component. This component is modifying this stuff, right? This is the class, the code behind for my template. Here's my template. There's different ways to look at this, but at the end of the day, you've seen it before in another form, guys. Okay. Here's an example of we're getting the sample component in. I'm importing my sample component, right? I'm using it as sample component. And here's my custom directive, right? Sample component is my directive. And what I can do is I can use sample component, sample-component, which is, if you notice, the selector for my component that I imported as a nested component. So here's my sample component, close sample component. And then I can also use my own selector, mean_app. So mean_app would be the outer component, and sample component would be the inner component. We would inject those two things inside, right? And we're going to see more of that. But it gives us flexibility in terms of how we build up components from the ground up. It's almost like we combine components to make larger ones. Okay. Services are tricky. Services are used for things like data management, logging, application configuration. A lot of times what we do is we consume a service with Angular or a factory. And I want to point it out to you. Sometimes we can send JSON data to Angular, especially from things like MongoDB or some kind of database. Angular can look at that JSON data, consume it, modify it, and spit it out using its own template, right? Dependency injection is something that's been around for a long time. And it's the idea that we can identify modules that are required for objects or parts of applications to work, to function properly, right? And again, the idea is from if we're going to use a term, it's the inversion of control from a software development perspective. It means the controller is in the dependency, not in the local method. So let's take a look at that. So here's an example of a method, right? And one of the questions I always get is, so what about this user service here, right? So this user service dot get user. Okay, cool. Here's this user service up here. Now we're making notifier. This notifier is the constructor, and notify, this part down here, right? Notify is the method that's part of this notifier class, right? So because I've linked notify itself to the notifier constructor with my prototype keyword, it is part of the same class now, and I should have access to something called this.userService. Now what I can do is I can say this.userService, whatever that was, .getUser. But the problem, what I'm doing here is I'm establishing a new local version, a local anonymous object of type user service in here. And I'm not able to pass this back out. I'm just doing it locally, right? So here I'm independent. I don't need to have, I'm not using dependency injection at all, right? Which gives me I have more control in this case. And that might be a bad thing, especially since I'm not passing information outside of the class. However, let's take a look at this example where I'm passing the user service into the object, the class, the constructor, right? And I'm assigning a reference of the user service class or object, whatever it is, to this local instance of the user service. And then when I do this, whatever I do with it is actually happening outside of the class because I'm using that same reference. It's a pass by reference instance. Now it's hard to understand some of this stuff. And the best way to think about this is when I pass in a dependency, my app manifest, the main app module, if you will, needs to understand all the app components that are part of my Angular 2 application. So I need to inject them as a dependency. And here's an example of using dependency injection. Okay, so I've got some service as an example with some component, and notice that I have a selector which says some component, and my template is hello services, and I'm taking my service and I'm using the provider's keyword to inject it as a requirement inside of my component template. And then what I'm doing is in my constructor, here's my some service, here it is. This some service local variable is actually being passed in from this service into my constructor and back out into my template. Okay. Again, a little difficult to see, but we're going to do this when it comes to authentication. We use authentication next week. And when it comes to using the built-in services that we have, the structures that we have today, we're going to use this next week. Okay. I'm not going to go too much further into this. Routing. So not only does Angular have its own templating system, and not only does it have, it's this idea of component-based architecture, but it also has its own routing system, right? Remember, because it does not depend on having a back end. Angular can work with any back end. You can combine Angular with PHP, or you can combine Angular with ASP.NET, or Node.js, or whatever the back end you want, or make your own back end, right? So it needs to have some way of routing and navigation. And so it includes a module like this. And it kind of uses this idea of the browser's history API to, in order for it to understand where it has come from and where it's going. In order for us to kick this off, you need to put this tag right here, base href equals to / just underneath the head tag of your main template. All right. Once you put this in, it tells Angular 2 that main or Angular routing can be enabled. It's very simple. Here's an example of some routes, right? Where we have the home routes itself is a type of route, which is equal to this path. What's the path for the home route? And what's the component? It's the home component. And of course, the home component comes from this home.component file that we're importing. We're getting a reference to the home component itself. So this is the way it does routing. And we're going to see more examples of that next week. There's also the idea of a router outlet. Sometimes we have one module that's kind of layered instead of another one, and we can use the idea of a router outlet to inject one module inside of another one. Let's move on. There's also the router link directive, which we're going to see when we use Angular to create navigation links, right? So we use router link, and then here's an example of, with these square brackets, a link to, kind of a route. Here's a route we're going to go to, and there's some kind of link that we're going to go to. So there's some link. Here it is. This is the about page that we're going to go to, and we indicate that the property is a router link or an anchor tag that we're going to use in a navigation. All right. Whew. I don't know about you guys, but I'm tired of talking. It's like crazy, like a long time, right? 4 o'clock already. Right? Okay, here's what I'm going to do for the next half hour. I'm going to set up Angular 2 to work with our current application. All right? Now, in order for us to do this, we need to do something pretty darn drastic. I'm going to make another duplicate of my application. I'm not going to change my app. I'm going to leave that pristine GitHub application up online for us, right? And we're going to add an Angular. I'm going to show you how insane it is. And you guys probably, if you guys started your lab 3, you've been seeing the shims and everything else to get it going. It's not so easy to get it going, right? Okay, let's try this out. So again, going back to my operating system, I have here's my COMP308. What I'm going to do is I'm going to copy my lesson 8b and call it lesson 8b-Angular. All right, so I'm going to just duplicate this thing. All right. And also, if you noticed up in Slack, right, while I modify this thing, I have some files, some snippets that I've put up on Slack for you guys earlier today. So if you look at the developer part, I've kind of put in things like a bunch of little files here, right? I've got a tsconfig.json file, a tslink.json file, a package.json file, an angular.ejs file, a bootstrap.ts file, an app.module.ts file, and so on, right? These are all required, believe it or not, to kick off your app, okay? So if you wanted to follow along, I've included these so that way if you follow the PowerPoint presentation, which if you notice, it's going to ask you to do certain things, like, for example, the package.json file is like 5 slides, something like that, long, right? So instead of having to copy and paste or try and slog it out on your own, I don't recommend. Just use the file that I dropped into Slack. All right, so why is it so complex, right? Well, first of all, let's take a look at 8b, right? I'm going to drag it. I'm going to kind of, first of all, stop any kind of debugging over here. So I'm going to kind of put this Angular in there, and let's create a new project just like normal. So this is kind of a little departure from what we normally do, right? And I've got this Mongo session still going, as well as this local session, which we're going to kill for a second. And what I want to do here is modify things so it works. So this is lesson 8b Angular. And I'm going to put this up on GitHub too, right? First thing first, kill your node modules immediately, right? Don't let them live. All those alien node modules, the green ones, kill them. That's the first thing. Next, after you kill your node modules, I want you to, if you're following along, we're going to go into bower.json and make some modifications. We're going to say 8b Angular, right? And same thing over here, lesson 8b-Angular. Okay, there we go. And package.json, okay, _Angular. Okay, there we go. And I'm just modifying these, that way they're compliant with everything else we've done today. _Angular. All right. You don't have to do this. I just like to change my stuff when I create a new module. All right, cool. So we've got everything going on here. This is my Angular code, and I want to get rid of my package.json file. So I'm going to bring up this, as well as I have this other project that I was working with earlier. So this is the project. Oops, let's try that again. I meant to my desktop. So this is my local project, my server, and I have a package.json. I'm going to delete it on my 8B Angular, delete it. And what I'm going to do is I'm going to take my package.json from my Angular 2 snippet that I made earlier or last night until very early this morning. Paste it. So it's my package.json. I'm also going to take some of the other stuff that I want in here. For example, my tsconfig.json, my tslint. I'm going to take those two things, copy them, and put them in there as well. And there's also other things inside my client. If you want to follow along, inside my client folder, inside my scripts folder, there is a system.js.config.js inside the lib folder. Please don't try and rebuild this yourself. This took most of my time to figure out what's going on here, and I'll explain this in a second. I'm going to copy this piece, and I'm going to put it inside my client scripts lib folder. Okay. I'll also take my favicon. Why not? Take my favicon and put it inside my client folder. So it has a favicon. We'll enable favicon later on. So there's this part. And inside my app, I have my app folder. I'm just going to take my whole app folder and copy it and put it inside my client folder. These are all the changes I have to make, and I'll explain these things in a second. I've already given you all these files, by the way. I've only given you 3, not the 6 or the 9, I mean, because I want to transpile them later on. I'm going to show you how that works. Okay, so those are there. I think I got almost everything. Also on the server side, in their views, in partials, I have my footer, my header, and I also have an Angular partial that I'm going to add in, because we need to have that in there as well. So I'm going to go partials. Here's my Angular EJS. Copy that one. And going to partials and paste. There we go. Wow. So lots of stuff going on to get this all going, right? And we're almost there. Okay, cool. So this is a great starting place, right? What I'd like to try and do, also look at these 20 changes that I made, right? But I'm going to kill my repository. I don't want my repository to be this way at all, right? So I'm going to open up a terminal. And I'm going to say remove.-rf.git. So I'm going to remove my git file, git init, git add dot, git commit -m, initial commit. Right? And then after I've done that, what I want to do is I want to create a new Git repository just for this stuff so that we're clear on everything I'm doing. So I've done 8A Angular, now I'm going to do 8B Angular. So new COMP308-W2017- lesson 8B-Angular. And I'm going to take these last few files here and populate them in here. And now you have my files up online. They're not complete yet, and I haven't had a chance to run them. So I'm going to kind of building things up here for a second. First things first, I want to do an npm install, right, which is going to install all my new node modules, right? Why did I kill my node modules folder? And I said, kill it again, because I noticed that when I changed my package.json file, there were some older modules. By the time I uninstalled and everything else, it was just easier for me just to incorporate the new modules by hand and reinstall them by doing an npm install. And there's less conflicts afterwards. So if you're going to base your project off of one of my files, you're going to know that my node modules are clean. Like I've already updated the modules to what they're supposed to be and so on, so it should work.
Actually, as we were working on the project, we noticed that some of them are changing versions.
Well, be careful. Once you start changing versions, sometimes they don't work, right? And that's the problem. I mean, that's why when I give you stuff, it's stuff that I've tested. So typically it'll work. And it's not good always to just randomly update. Okay, so now that's one. Now there's still pieces that are missing. And if I follow the PowerPoint, I've done this piece. I've done all this. This is my package.json file, right? and we're going to talk about what these things are, right? So if I look at my package.json really quickly, and the top part is here are all these new Angular dependencies. Look, take a look. Whew, right? A slew of them. For you to go there and install them manually yourself, that's nutty, man, right? And by the way, you don't want to get the latest versions. You want to stick to these. Notice that they're all the same, 2.45. There's a reason for this, right? Because they're all made to work together, right? You try and download random versions that they may not jive, right? Or they might be out of date, or they may need additional typing or whatever. So stick with the, when you build up an Angular application, don't build it from scratch. Use my scaffold for this semester, okay? Or go up online and get the scaffold online. There's Quick Start, Cedar application, right? We use Core.js again, and React.js, this is Reactive.js is what it is to help us. System.js is for modularity. Zone.js, again, is for backwards compatibility. Then the rest is all of our Barty parser and Express stuff. This is all the old stuff we had before. We also had in here a bunch of dev dependencies. Notice I had at types. All these things here give you code hinting for Angular. If you don't put these in here in the right way and the right amount, what'll end up happening is you get a bunch of TypeScript errors. You'll say, well, there's a bunch of errors here. TypeScript's not working. It's because you don't have the right typing it's in here. And at types, these types give you type definition libraries for all of your front-end dependencies. There's also a bunch of other things. For example, notice that we have Jasmine here, as well as Karma and Protractor. If you look at anything like Karma or Protractor, or even the stuff you've done for your Lab 3, those are all, anything you see E2E, that's end-to-end testing that you are not required to do, right? We won't be talking about testing in this class. We just don't have the time. Although it's a great thing to wrap your mind around. So more and more, these are dev dependencies. These are all things like concurrently. Concurrently, what it does is it runs two things at the same time. And if you notice, we have some new scripts here. We have a TypeScript. If you don't have TypeScript locally installed in your system, it installs it for you. TSC -W puts TypeScript in watch mode, which watches for any file changes, and then it restarts your server again. All right, so it's really, really cool. And concurrently allows you to run both TypeScript and your application at the same time. You don't have to do this anymore. This is kind of deprecated because we don't need to do a post install since we're not using typings anymore. We're using @types with npm. Whew, so lots of dev dependencies, and that's why I didn't want you to type the whole thing in or try and generate it yourself. It just makes no sense. And this is the one thing about Angular 2 as well as Ionic and a bunch of new frameworks that really bugs the crap out of me, because you can't build it from scratch. You need to have their Cedar file, right? It makes sense because what the Cedar file does is it creates a scaffold for you. But it'd be really nice if we could just generate this on our own. And it takes a lot of effort for you to do this, right? Trust me, I went through it yesterday. So lots of dev dependencies here. And then finally, we were back down to our stuff. So that's our package.json. Then we also included a tsconfig.json, which is our TypeScript configuration file, right? Which basically tells TypeScript how to transpile things from TypeScript to JavaScript. Here, we're targeting ES5, ECMAScript 5, the old version of JavaScript. That's what we're targeting here, right? And we're using the system.js modular way of doing things, right? So the way we import things. We're also using node module resolution because it's a node application. Source maps basically create an extra file every time you transpile, along with the JS file. Remember that browsers don't understand TS files, .ts. They only understand .js for JavaScript. So you transpile, you get a .js file, but you also want this map file a lot of times, because map files, what they do is they make troubleshooting easier, debugging in the console, right? And they actually point back to TypeScript lines of code as opposed to the JavaScript side, which may not make any sense after it's been transpiled, right? So that's why source maps are super important. Emit decorator, metadata, and experimental decorators are explicitly for Angular 2. You need to turn those on. Remove comments, we turn that off so we can see all of our comments. No implicit any, false. That means that we allow implicit any declarations. And implicit any means somehow TypeScript will go through your code and try and transpile. And if it doesn't understand what the type is going to be, it's going to assign the type of any. And sometimes we turn that off if you want to be strict. So we put in no implicit any is true. We'll make it very strict. So it won't allow implicit any, and it'll give you an error, throw an error, right? For now, we've turned it off. Suppressed implicit any index errors. We've turned that on to true, though, because sometimes index errors happen with arrays. So we turn that off. We can also indicate what things to exclude, and we definitely don't want to transpile node modules. Because that would be like transpiling on top of transpiling on top of it. It would be a recursive loop. All right, so we definitely exclude node modules. All right, so that is our tsconfig.json. tslint.json actually is a linter that checks to see if our TypeScript is, created properly or formed properly. A web config we've had on from last time, from before, we haven't changed that, right? So this is what we've done so far. Inside of our client, now this is what I told you took a long time. If I go to client scripts, inside there, there's something inside my lib folder called systemjs.config.js. My friends, you cannot live without this file here. If you try and make your AngularJS2 file run without a systemjs.config.js, it won't work, right? It'll give you a zone error, right? And that's the biggest pain in the ass. When you look and go, zone error, what is that? It's this, all right? And what it is this has to point, especially in Angular and Node, it has to point to where all of the Angular files are located inside my Node modules. That's one job that it has. The other job that it has is it has to say, what's the default extension type? So I don't have to always put in, here's my app module.js. I don't want to do that all the time. I just want it to know that it's my default extension is JS, okay? So in order for me to get there, so I don't have to say node modules, Angular, core, bundles, core, umd.js, as an example. I don't want to go there. I have to modify my app.js, which is inside my server, to include the same kind of thing that I did with my client, where I app use a static route for my client. I want to do the exact same thing from node modules. And if you notice in the PowerPoint presentation here, if you skip through here, where I'm going through this stuff, there is that section right here, right? Tells you what to do. So if you follow the PowerPoint presentation, it'll help you build your code out, right? Why am I giving you this stuff? There's always an underlying reason, right? Because when you do your final project, you're going to say, Tom, I'm building up my final project, and I don't know where to start. And I'm going to say, start at lesson 8B, Angular, right? This is a good place because this is where we're starting. Or maybe I'll tell you, start at lesson 9B, because next week we're actually going to put things together. So you can have a basis for how to look at that code, because that is a good example of how things combine with Angular, if you wanted to use Angular. But I've also kept Angular separately. Why? From the regular code, just in case you decide, I'm not touching Angular for my project, right? You don't want to get the bonus. All right, so here's node modules, and here's our client. We need to put this in, so I've put it in. So save. Right, so now that I've got this in, the next part is in my views, right? I remember I put in this partials called angular.ejs, and these are our polyfills. Oh my God, what a pain in the ass this is. Polyfills are a good example of a lot of older older browsers that are not Angular 2 compliant. So you need to add in these shims and polyfills in order for us to make things work with Angular, okay? And also notice that we're using systemjs.config.js right here. We're actually calling it and then activating it here at the bottom. This is required. And so if this is required, I need to include it somewhere in my footer, all right? Either in my footer, or if I look, I'm going to make a demo, right? So I'm going to go to my contents inside my index.ejs. I want to put it down here. So my footer, what it does is it loads in jQuery, Bootstrap, and app.js, right? My own app.js, right? Well, I want it to inject this before the footer. Notice it also has my footer, right? Well, I can do that by going to here in my index and just including it. So I can go something like % include / partials. Then instead of footer, it's going to be angular.ejs. Okay. So what this does is it injects those polyfills right at the bottom of my code. Okay, cool. And the other thing that I want to do now, in order for me to test everything out, is underneath here, if we're going to test, right? So I'm going to go with this for a second. So Again, this just talks about your application architecture, how it's going to look at the end, right? Something like that. And here is an example of the three modules that I'm going to talk about. I'm going to come back to this in a second. So I'm going to skip down a little bit. All right. Here's my system.config.js, right? And this I need too. So at the top of my header, I need, remember I talked about this, I need this base href is equal to / this is all set up, by the way, for Angular. Basic setup with no functionality right now, all right? I need this to come to the header of my file. So I'm going to copy this. I'm going to go back to my code. And if you look at the header, right? So here's my header. Just underneath the head tag, put that in. Again, good thing is it's being recorded, so you can always go back and go, what was I missing? Oh yeah, there's the header. There's that head part. Okay, that's required because that allows Angular routing right there. Okay. Cool, cool. And if I skip down a little bit more, you see there's two files. One of them is this polyfill file, and the other one is this, my app. Right? I'm going to take this, I'm going to put it inside of my index.ejs file, which is right here. And I'm going to explain what this does, right? Because you should already know. But my app is my custom directive, my custom tag that I made within my, and again, if I go to my app folder inside my client, if I go to my app.component.ts, you can see that I'm using my-app, right? Which is going to say hello, and then I'm using interpolation to plug in Angular. So when I go into my index.ejs, and here, there is something in the middle. This is called fallback text, right? Fallback text, which means if somehow Angular fails or is incompatible with a browser, it's going to produce that text, loading app component content here, or if it's too slow, right? And you'll see this sometimes frequently change. You'll show this for a second and bam, it's going to show hello Angular, right? But that's where this container, this app, my app, right? This app, my app tag is the container where it's going to inject the Angular template. Okay, this is where it's going to go. So what are these files that I'm adding in? I'm adding 3 of them, right? I start off with my app component, where I declare my selector, my app, my template, which is inline. Notice I'm using backticks for this, right? And then my app module. My app module is my app manifest, right? It's the thing that binds my app together on the Angular side of the house. My app manifest on the server side is my app.js, where I do all my requires. Okay, that's my app.js. But here I'm doing this part, where I kind of specify my imports. My declarations are my dependencies, and I also want to bootstrap my dependencies. I want to do both, my app components in my declarations and my bootstrap. Then finally, my bootstrap itself, which basically, and by the way, you don't need these 2 things. I'm just going to get rid of these. These are just my troubleshooting from last night. And then if you look at this, what I'm doing is I'm importing my platform browser dynamic and my app module, which is my manifest, and I'm bootstrapping my app modules. This is the entry point for my client-side application right here. Okay. Once I've done that, finally, I'm able to transpile and make this go. That was all the configuration. Just putting that together took me about, what, 25 minutes. Let's try this out. So here I am in my Angular, and if everything goes well, I'm not going to go npm or nodemon anymore, right? I'm going to look at my package.json, right? And notice what I want to do here at the top. My script is going to run concurrently. So I want to do npm start. So npm start. If I've done everything correctly, and if I've saved everything, it's going to transpile nicely. If I failed to do something or I forgot to do something, it will not transpile. And it looks like I'm okay. If I change anything, it looks like I haven't saved everything up here, but if I do, so I go File, Save All, right? If I save all, and if I go back to my files, you can see that it will, not this one, it will reboot and run it again. So any file changes that happen for TypeScript. Okay, now to tests. Here's the test. So I'm going to go up online, I go here, and now it said this is my original version, right? Localhost 3000. What it should do is if I press refresh, it should show hello Angular and then home, welcome to home. Okay, let's try this out. Refresh, hello Angular. And see how that momentarily showed me my fallback text? It was loading up Angular. And now I've injected Angular 2, an Angular 2 component into my index.ejs page. Now, you see the complexity of what I just talked about here? The setup involved for me to get here? That's why I'm not asking you to scaffold. I'm not asking you to do this. It's not going to be a requirement for your project. It's going to be bonus, right? Because if I make it a requirement, a lot of you people may not be able to do it, right? Or it'll just add complexity to your project that's going to really slow you down. And it's not, this is not the only course you have, right? So that's what I understand. Okay, let's upload this to GitHub, right? So I just made all those changes. So I'm going to go here. I've got 8 little changes, and I'm going to say things like updated project for Angular 2 setup. All I've done. Now, you might say this is really complex, and it is. But next week, what we're going to do is we're going to make our app work alongside with Angular. I'm going to take 2 streams here, okay? It's going to be like a tale of 2 cities. I'm going to leave our app at version 8b, our original app, the non-Angular one. And then I'm going to take our app 8b with Angular and move on from there. So leave that other one aside, right? Which we can always go back to, and we will, right? The other thing we're going to do next week, again, this is just a preview because I'm winding down everything that I've done for today. I'm tired of talking, that's for sure, right? I'm going to close this off for a second, and I'm going to close some of these off. What I'm going to do next week is start talking about Firebase next week or the week after. Firebase, we're using Angular for pretty much everything, and the way to get to Firebase, by the way, is go to firebase.google.com. Firebase is a Google project, right? And what it allows us to do is connect with a serverless SQL-less or no SQL database on the back end. You can actually connect to it for free. Firebase is really great because there's a couple things. One, here's a node project as an example. Here's an example node project, right? It allows us database access. So let me take a look at this database. So here's an example of our games database, right? With, what does this look like? It looks like an array, right? So this is how it stores everything. And I noticed I can have multiple arrays that are listed here, right? So here's our array, here's our other array, and I have a couple of arrays here on the database, right? It also does authentication. So I don't have to use Passport. I don't have to use Passport. I don't have to use Mongoose. I don't have to use Mongo. It's all on here on Firebase. It also does storage, where I can serve up files, audio, video, images, whatever I want to do, right? So storage part. It also does hosting, right? And a bunch of other things. Firebase is quickly becoming very popular when it comes to mobile application development. Why? Because it has, especially when it comes to development, and I'm going to go back to my overview for a second, right? So the great thing about this is, if I go to Docs, it has documentation for iOS, Android, Web, C++, Unity, right? From a back-end perspective, it can't be any easier. It's a NoSQL database, and it's quick and slick when it comes to using it. Now, if you're someone who's interested, and if you want to push yourself a little bit, you want to challenge yourself, which maybe there's someone out there who wants to. I've already created a version of our code that connects to Firebase based on our version less than 6b, which I'm going to update at one point. So if I go to github.com, and if I go to just me, right? So it's not Centennial or anywhere else, right? And if I look at my files, right? So let's take a look at my repositories. You can see that I've got this W2017 Firebase, right here. Now, even though I updated 9 hours ago, I've been working on it for a bit because it's been from 6b. And what this does is it connects to Firebase, right, as opposed to Mongo. right? So there is no Mongo connection here whatsoever, not required. And it does authentication as well as database with Firebase. Why Firebase? Because of iOS and Android. So you build an app with Angular, right? You have a back end. And guess what? Your iOS and Android applications connect to it too, right? And so does your game, right? Unity. There's great opportunities here. And it's like, again, quickly becoming the de facto, I'm going to say standard, but very, very popular back end, right? Also, it combines nicely with something called Ionic, right? Part of the course that we're going to be doing this semester is, not including microservices, is we're going to be using Ionic, which uses Angular 2, TypeScript, and Node.js with Cordova, Apache Cordova, to produce hybrid apps for mobile, right? Same technologies we've been using all along, right? We're just going to reuse them to create a mobile app, right? One of your little projects or whatever you're going to be doing. And on top of that, it combines greatly, amazingly, with Firebase again, right? And they have an actual, a really cool project that they've been using for a while called Angular Fire 2, right? Angular Fire 2 is a project that allows you, an API that allows you to tie into Firebase. So really, really cool. You know, you can see that it's the same component architecture. Take a look. This is Ionic, right? Here's Ionic right here. And it looks like an Angular application, right? So once you learn Angular 2, you can leverage your skills from Angular 2 to build out a hybrid mobile app that you can use basically to create without having to know anything about Java or Swift or iOS, Xcode, Android Studio, none of that stuff. You can prototype a mobile application very, very quickly, right? And with Ionic, the great thing is you have access to use something called Ionic Native, which allows you access to the metal, which you can do things like use your camera API, or you can have your battery status, or you can do any other things that you want here, right? So really, really kind of kind of interesting stuff here, and all with the same web technologies we've been learning from the beginning, right? So this is all the stuff that we're going to be doing over the next several weeks. That's why the second half of the semester, right, is exciting and difficult, right? Because it's, like I said, it goes from, basically middling to intermediate, I would say, and then now we're going from intermediate to advanced, right? So hang in there. I know it's challenging, and sometimes it can be scary with all the stuff we're talking about, but remember, I'm only going to make the core modules that we've ever used. That means Node, Express, and Mongo. Those are the only things that are going to be required for your final project. Anything else on top of that, there's going to be opportunities for bonuses and to build out your app the way you want. Express, Node, and Mongo, like we've been doing right now, which is everything you need to know. You can actually start your project today if I gave it to you, right? Because you have all the knowledge you need. That means full CRUD already, you know how to do, and authentication, right? Questions? I didn't run any faster the second half than I did the first half, right, at all. It was like a lot of work today, right? And I know the other sections are cruising at a different speed than us, all right? Please don't be kind of scared away by it, right? Someday they're going at a different rate than we are, right? And they're also scratching the surface a little differently than we are, right? They're taking more of a glancing blow at Angular than we are in some ways, and they're doing deeper things in other ways. Remember, one of the things that took a lot of our time today is refactoring our code base so that it was MVC capable, right? MVC compliant. So that was part of what we had to do today. But I'm doing this in the hopes that it'll give you more understanding at this stage. Questions? No, I'm going to make it optional for Angular, but it might have something to do, because I'm going with Ilya's assignments. We might also go with something to do with microservices, because microservices is also a 3-week component of our second half, right? So, and microservices to me is one of the most difficult things to learn, right? Because at first it becomes non-intuitive. Again, with microservices we use Express and Node and Mongo, right? Or some kind of WebSocket, okay? One of the applications I built recently with microservices is a little tutorial I was doing where we built a Slack bot, right? Where it actually uses natural language processing with something called wit.ai, where you can actually create, here's my first app. I made this Dr. Strange bot, right? And what the Dr. Strange bot does is it answers things like, what time is it in Dubai? You know, what temperature is it in New York? You know, one of those kind of things, right? So we're going to try and do this kind of stuff. And if you actually look at it online, so if I go to, if I actually was to kick this thing off, I don't have it running right now. But you can see press to chat with your bot. And if I go to, you know, so if I look at stories, you can create your own story and all that kind of stuff. You can see that if it's online or not, right? So you can create your own stories. Basically, are a way of you mapping out what, if someone asks a question, how you respond to it. And you have something called intents that you can use. So an example, you might have a question that says, what time is it? Time is it in Dubai? Location. So it looks at those two things and says, okay, cool. He's asking for time and location, return time and location, right? And there's different ways of saying it. Like, for example, here's another one. How late is it in Dubai? Late, that could indicate time, or early, right? Because another way of saying what time is it, right? Dubai is still location. So different kinds of ways of creating a story to create this whole idea of natural language processing to respond, right? And then tying it into Slack, if I think I did it on my own channel here. Let me see if I have it running, right? Oh, maybe I didn't do it here. But what we can do is we can kind of connect it. Oh, here's Dr. Strange. Yeah, see, I knew it was there. Right, there's Dr. Strange, right? Sorcerer Supreme of Earth, right? So I made the Slack bot, and what it does, it can respond. It can say hello and that kind of thing, right? So we're gonna think about doing that with microservices, all done with microservices. I guess we'll talk about that. So that's kind of coming up. We're gonna have a 3-week slot of microservices, right? A couple weeks of Angular this week, next week, and maybe one will fit in another week in there with Ionic. Okay, any questions for today? I know we covered a lot. Remember that Lab 3, which is your Tour of Heroes, a working version of your own, must be ready by tonight to get the bonus, right? I know people are like, Saturday night, what are you giving me this work for? Okay, don't do it, right? But it's worth 2%. This doesn't take long. It'll take you an hour to go through, right? 1 hour, huh? Then an hour? Yeah. Okay, 2 hours. All right.
2 hours will take me 8 hours.
Yeah, there you go. Any questions around this stuff? All right, guys and girl, take care. We'll see you next week. Remember, next week we're doing full CRUD with Angular 2. So be prepared for the craziness. I know. Don't moan too much. All right, thanks. Take care.